My first suggestion on D is to do exactly the same thing that I said on part C. Anytime I have a set of parentheses like this, I will simplify the stuff inside the parentheses before I focus in on what's happening outside the parentheses. So I see then that I have a 2 here. And again, that 2 has a positive exponent. So that means he's not moving. Then I have an x to the negative third. X to the negative third in the numerator is equivalent to x to the positive third in the denominator. Y to the negative eighth in the numerator is equivalent to y to the positive eighth in the denominator. And then we have a z. Once again, notice that z has a power, it just doesn't have to be written. That power on that z is a positive 1. And because the power is positive, he's not going to move. So I'm going to have a z still in the numerator. And then I have y to the negative second in the denominator. Once again, negative exponents move things. So y to the negative second in the denominator is equivalent to y to the positive second in the numerator. Now you'll notice that I'm going to put that y to the positive second in between the 2 and the z. There's a tradition when you have lots of different variables like this to alphabetize the variables. So that's why I put the y in front of the z term. So now that we have that then, we still have this negative fifth power piece. But, am I done simplifying inside the parentheses? The answer is no. I still have a y piece in the numerator and a y piece in the denominator. So anytime you have the same variable in both numerator and denominator, you're not done with the problem yet. So we need to figure out how to play with this y to the second divided by y to the eighth. Well, we've actually seen 2 different acceptable ways of moving forward. One is to say that we have y to a power divided by y to a power. That would be an example of the quotient rule. And on this particular problem, after we use the quotient rule, we would then have to think about what happens with negative exponents. Another way is to say we have y to a power divided by y to a power. We can think about it in terms of cancellation, and that's what I'm going to choose to do. I'm going to cancel 2 copies of the y from the numerator, leaving me with number 1. And then if I cancel 2 copies of the y from y to the 8th, we're going to be down to y to the 6th. So what that means then is that my numerator has become 2 times 1, that's just 2, z divided by x to the third, y to the 6th. So now that I have simplified everything inside the parentheses, this is the point where I'm going to focus in on the negative 5 power on the outside. So once again, when you have a fraction to a negative power, the whole fraction is going to flip. So everybody in here is going to change. So we have a 2 that's going to go into the denominator. We have a z that's going to go into the denominator. We have an x to the third that's going to go into the numerator, and a y to the 6th that's going to go into the numerator. At this point, the negative has done his job, so that goes away, and we still just have a power of 5. So now that we have that power of 5, we can bring that power of 5 down to every single piece inside the parentheses. Because again, everything inside the parentheses is connected by multiplication or division. So we have the expanded power rule that allows us to bring that power of 5 down to everybody. So we're going to have x to the third, he gets his copy of the 5, and then y to the 6th, she gets her copy of the 5, and then we have 2, its copy of the 5, and the z is going to get its copy of the 5. So now it's a matter of coming in and simplifying each and every one of these pieces. X to the third to the 5th, once again an example of the power rule. Power to a power, we're going to multiply those exponents. So we're going to have x to the 15th. Y to the 6th to the 5th, once again an example of the power rule. 6 times 5 is going to give us 30. So we have y to the 30th. And then in the denominator, the first piece is simply a number problem. 2 to the 5th power. Multiply 2 times itself 5 times, and we're going to end up getting 32. And then we have z to the 5th. Now that's just going to be z to the 5th. Now at this point, it's always a good idea to double check to make sure that you did all the simplifications that were required. If you still have an x that's in the numerator and the denominator, you're not done with the problem. If you still have a y in both places or a z in both places, there's more simplification that you can do. So you double check. You'll notice here that we don't have multiple copies of the x, we don't have multiple copies of the y, multiple copies of the z, or lots of constants still running around. So that gives us a sense that this is probably going to be an acceptable answer. So, in fact, it is. And it is the final answer for this particular problem.